Desalination is the process of taking unpurified water and turning it into drinkable water. This will revolutionise the future and will provide us with fresh water when the aquifers and dams run out of our water source.
Reverse osmosis. The first step is that the valve that fits onto the cold water supply line. The valve has a tube that attaches to the inlet side of the RO pre-filter. This is the water source for the RO system. The next step is the pre-filters. Water from the cold water supply line enters the reverse osmosis pre-filter first. There may be more than one pre-filter used in a reverse osmosis system, the most common being sediment and carbon filters. These pre-filters are used to protect the RO membranes by removing sand, silt, dirt and other sediment that could clog the system. Additionally, carbon filters may be used to remove chlorine, which can damage the RO membranes. The third step is reverse osmosis membrane. The reverse osmosis membrane is the heart of the system. The semi-permeable RO membrane is designed to remove a wide variety of both aesthetic and health-related contaminants. After passing the membrane, the water goes into a pressurized storage tank where the treated water is stored. Step 4 is the storage tank. The standard RO storage tank holds from 2 to 4 gallons of water. A bladder inside the tank keeps water pressurized in the tank when it is full. The typical under-counter reverse osmosis tank is 12 inches in diameter and 15 inches tall. 5 is post-filters. After the water leaves the RO storage tank, but before going to the RO faucet, the treated water goes through a final post-filter. The post-filter is usually a carbon filter. Any remaining taste or odours are removed from the product water by post-filtration polishing filter. 6 is automatic shut-off valve. To conserve water, the RO system has an automatic shut-off valve. When the storage tank is full, the automatic shut-off valve closes to stop any more water from entering the membrane and block flows to the drain. Once water is drained from the RO faucet, the pressure in the tank drops. The shut of the valve then opens to send the drinking water through the membrane while the contaminated wastewater is diverted down the drain. 7. Check value. Check value is located in the outlet end of the RO membrane household. The check value prevents the backward flow of treated water from the RO storage tank. A backward flow could rupture the RO membrane. 8 is flow restrictor. Water flowing through the RO membrane is regulated by a flow restrictor. There are many different styles of flow controls, but their common purpose is to maintain the flow rate required to obtain the highest quality drinking water. The flow restrictor also helps maintain pressure on the inlet of the sides of the membrane without the additional pressure from the flow control. Very little water will be produced because all the incoming water would take the path of least resistance and simply flow down the drain. The flow control is most often located in the RO drain line tubing. 9. Faucet. The RO unit uses its own faucet, which is usually installed on the kitchen sink. Some areas have plumbing regulations requiring an air gap faucet, but non-air gap models are more common. 10. Drain line. This line runs from the outlet end of the reverse osmosis membrane housed into the drain. The drain line is used to dispose of the wastewater contained.
There are many pros and cons towards desalination. The pros are that we will be able to have fresh water to last us for the future, but the cons are that desalination uses a lot of force and will drain out a lot of the electricity from fossil fuels. Also the fact that all unpurified water will be sent back into the ocean, which will concentrate the salt levels in the sea even more, will become a big problem for ocean wildlife and for more desalination of the water.
One desalination plant provides fresh water for 375,000 people on average. During the first 5 decades, public and private investment in developing desalination technology has reached more than $1 billion worldwide. It costs from $800 to $1,400 to turn 123,259 litres of salt water into fresh water for desalination.